So we looked at our tangent graph in our last lesson. Now we're going to look at our cotangent graph. And remember, cotangent is the reciprocal of our tangent. So its graph is actually going to be very similar to our tangent graph. So note that cotangent of theta equals 1 divided by tangent of theta. So if I wanted to make a chart like we did with our tangent, we could do that very easily by just taking our outputs for our tangent and finding the reciprocal. So notice that if I started at 0, well, we know that tangent was 0 at 0 from our previous chart. So we would be taking 1 divided by 0. Well, 1 divided by 0 means that this is going to be undefined. And we could do the same thing with like our pi's over 6's or our pi's over 3's, but because those have square roots for our tangents, they'll also have square roots for our cotangents. And again, remember that we can plot any points that we want to, but most of the time we want to stick with our key points, the ones that are going to be easy for us to graph. So if we look at pi over 4 next, remember that for tangent we got 1. Well, if I take the reciprocal of 1 divided by 1 is still going to give us 1. Next, if we looked at pi over 2, this is where tangent is undefined because for tangent we get 1 divided by 0. Well, if we flip that, notice that we would get 0 divided by 1. So cotangent is going to be 0 at pi over 2. Then at 3 pi over 4, it would be -1 for tangent. And then if I take the reciprocal of that, it's still going to be -1. And then lastly, for pi, we would have 0. So again, if we take the reciprocal of that, it will become undefined. Now, just like with our tangent graph, the period of this is going to be pi. So it will repeat itself every pi instead. And the graph is going to look very similar. So notice that I have undefined spots, just like I did on my tangent. So just like with my tangent, those spots are going to be asymptotes. The only difference now is notice that I'm starting at 0 as an asymptote and then going to pi as an asymptote. So because it's more centered, or it starts and ends at our 0, and we're going to get the full graph, we can go ahead and start that first cycle at 0, which is helpful because then just like our sine and our cosine, it makes it a little bit easier to find our phase shifts. So really, tangent is the only one that's a little bit different or a little bit funky. So we said at 0, it's undefined. At pi over 4, it's 1. At pi over 2, it's 0. And then 3 pi over 4, it's a -1. And then we're at 0 again. So if we notice, it is the same shape that we get for our tangent graph. It's just been reflected. So instead of being down on the left and up on the right, like our tangent parent graph is, it is up on the left side and down on the right side. And we can do the transformations very similarly to how we've done our other ones. So our first step is going to be to look at, okay, I have an A value of 2. Now remember that we can't treat this A value, it's not the amplitude, because just like with our tangent, our cotangent doesn't have a max or a min. However, it is still going to stretch or compress it the same way that it did with our sine and our cosine. And then here, notice that our B value is 1/3. And so to find the period, just like with tangent, I'm going to take pi divided by my B value, which in this case is 1/3. So we end up with 3 pi. Now what's nice is because unlike our tangent, our cotangent is going to start at 0. Remember, we want to set the inside equal to wherever we normally start. Well, because tangent was started at -pi/2, when I had a B value, it changed that as well. But because cotangent is starting at 0, like our sines and cosines do, just because there's a B value, that doesn't change our starting spot. So then to find the ending spot of our first cycle, remember that we take our starting spot and then add the period, and we get 3 pi. So notice that here our kind of pattern is very similar to the one that we have with our tangent. I'm going to start and stop at an asymptote. The only difference is my key point where that y value is 1 comes first, then we have a 0, then we have a key point with y equals -1, and then we end with an asymptote again. So sticking with that same format, I'm going to go by a little bit of a different increment on my x-axis because we have to get all the way out to 3 pi. So I'm going to go ahead and go by pi's over 2's. So notice that I would start at pi over 2, then I have pi, 3 pi over 2, here we would have 2 pi, then next we would be going another pi over 2, so we would have 5 pi over 2, and then lastly we would have 3 pi. Now remember, like with my tangent, I'm going to start and end at an asymptote, halfway in between. So at that 3 pi over 2 is going to be our 0. And then remember that halfway in between, we're going to be, normally we would be at 1, but notice that our graph has been stretched because of that 2 value with my A. So our graph would look something like that. And all of our other transformations are going to be very similar. For the most part, I'm going to focus on period changes and amplitude changes for tangent and cotangent. And then we'll look at more like phase shifts and things like that when we get to our cosecants and our secants.